All right, guys, so 2, 1. First thing here, does cosine of theta times cosecant of theta times tangent of theta equal 1? Let's see. So cosine times cosecant times tangent. We are trying to show that that equals 1. So we're going to try to rewrite some things to show that that works. So cosine, once you're at sine or cosine, there's really not a lot to do with it. So I'm going to leave cosine just as cosine. But instead of cosecant, what could I write? Not 1 over cosecant. 1 over sine. 1 over sine is cosecant. Okay. And then instead of tangent, how can I write tangent? Sine over cosine. Okay, good. So I'm only working on this side of my equal signs. And then what happens? Yeah, cosine over cosine, sine over sine. So what am I left with? 1. So 1 equals 1. Okay, guys, that was a proof. You guys are pros, right?
That better be the hardest proof.
Not quite the hardest, but that's the general idea, okay? We rewrote our expressions on the left, simplified until it equaled the right. So, I don't know if any of you have seen Fight Club. Mr. Matthews was having fun when he came up with this first part here. So, you know, there's the rules of Fight Club, there's the rules of our proof club here. That's what we're doing. Yeah, you can't talk about it. So, yeah. Now, the first one, you can only change one side of your equation. So you see how I do this? Sorry. All right, guys, so back to this first one. Do you see how I drew this line under the equal sign and then all of my work was done over here? Okay. That's how you have to do your proofs. You're picking a side. It doesn't have to be the left side. You can pick either side. And you're going to do the work all on that side. Okay? All right. Your second rule. You must try. Okay? Sitting and staring is not a strategy. So with a proof, if you think you're stuck, you cannot just sit and stare. Try something. It may not lead you down the right path, but it may spark something in your mind where you're like, oh, now I'm going to try this. Okay, so you have to try. And your final rule, you must try. Okay? Clearly that is an important rule. Don't be so afraid of doing it wrong that you don't do anything.
Okay, so this means that we'll get credit even if we don't get a correct answer. Or like we'll get some credit.
Okay, so on the homework, if you try and it's a completely wrong path and then you're like, I didn't know where to go. You tried it, you'll get credit for the homework. Quiz or test, if you don't get there, then you won't get the points. But there is absolutely partial credit to be had on these groups. So you might try something that starts off okay and then you get lost in the middle and you could get some points. Okay? But if it's just you stared and it's blank, you're gonna get nothing. Okay? Yeah.
Just out of curiosity, is like induction proof that covered?
We don't do proof by induction anymore. It used to be part of our, it used to be one of our standards, but it's just not anymore. So these are not induction proofs. These are just logical step-by-step equivalency type proofs.
I don't even know what it is.
Oh, okay.
No, it's like
It's interesting, yeah.
it's like K and then proof.
There is a K. Feel it. And then K plus 1, and you're plugging it in. Okay. All right. So let's try some. All right, so our first little tool here, the first thing we're going to try, we are going to rewrite using reciprocals. So as I look at this first one, when you're trying to pick a side to work on, it looks like there's more to work with on the left side. Do you guys see that? So that's the side I would pick. You may start on one side and go, oh geez, that did not take me where I thought it was going to, did not accomplish what I wanted it to, and then you go over and you try it again on the other side. That's fine, okay? Draw a line. So I am going to work on the left side. So we've got tangent of x times 1 over cotangent of x. Well, what is 1 over cotangent? Okay, so really I have tangent of x times tangent of x. And what is tangent times tangent? Okay. And so I'm writing tangent squared equals tangent squared. So a lot of sort of formatting things that matter with this, little details. Do you see how I'm writing the x every time next to the tangent? You have to do that. If it's theta, you write theta. If it's alpha, you write alpha. Like you have to keep the angle in every step along the way. This side, you don't have to write tangent squared in every step. You can just have it at the beginning and where you're ending. Every step over here has to be mathematically equivalent to the previous step. So when we get into some of the more complicated ones, you can't do like a partial step with some work and then jump to the next step. You will lose points, okay? So when I grade these, like tangent squared equals tangent squared, that's not like that's the answer. It's the work that I grade along the way. So you guys might get there in different ways. That's okay. That can happen. Some of you, you know, to get from here to the room next door, some of you will just walk next door. Some of you will take like 2 laps around the hallway and then get next door. You still both got next door. All right, that's okay. All right, let's try our second strategy here. We can split up a fraction. Can you guys see that okay? Is that an okay color, or would you rather have a different color? Split up a fraction. Split does not look like the word split. All right, so which side do you think we want to work on? Left. Okay. All right, when I say split up a fraction, what you can do I can put secant of x over cosine of x. And then I can put minus cosine of x over cosine of x. Okay. What this means, secant over cosine, that's really secant times 1 over cosine. And what is cosine over cosine? 1. Okay, does this make sense, guys? I've just split this again into 2 fractions, right? If I multiply this, I get right back where I was. And I'm going to run out of room. This box isn't big enough. What is 1 over cosine? Secant. So really, I have secant of x times secant of x minus 1. All right, what is secant times secant? Okay. So I'll just go into the box with the 4 here. So I've got secant squared x minus 1. We're really close. Do you guys remember your Pythagorean identities from last unit? Okay, we'll finish this one, then we'll review those Pythagorean identities. What is secant squared minus 1 for those that remember? Tangent squared. Well, beautiful. That's what I needed. Okay. All right, so let's do that as a side note here. Let's review your Pythagorean identities. So anywhere you want to jot them down. What's the original one that everybody should remember? Okay. All right, so that one is the one you must know. All the others are derived from that one. So if you forget the others, you can find them, but this one you got to just know. All right, does anybody remember how we found the other ones? Okay, so if I start with this, and I divide everything by sine squared, we've got our second one. What is sine squared over sine squared? 1. What is cosine squared over sine squared? And 1 over sine squared? Cosecant squared. So coming back to you. And remember, you can manipulate all of these. So if I saw in a proof, let's say I saw cosecant squared minus cotangent squared. What do we know that's equal to? 1. Okay? So just make sure you recognize, and you'll get better at recognizing them the more practice we do, seeing those identities over and over. So we have one more to find. So again, I start with sine squared plus cosine squared equals 1. And what am I doing this time? Perfect. All right, what is sine squared over cosine squared? Tangent squared. Cosine squared over cosine squared. 1 and 1 over cosine squared. Okay. So I think in the proof we just did, we had secant squared minus 1, right? You guys see how that's just the manipulation of moving things around here? Yeah. So a lot of just recognizing these formulas and different versions of them. What do you think? Do they have to be squared? Yes. Okay, they are the Pythagorean identities. They come from the Pythagorean theorem, a squared plus b squared equals c squared. So you cannot have sine plus cosine. That doesn't equal 1. Okay, they've got to be squared. All right, so those are now a little fresher in your memory, right? Okay. Let's try another approach. Okay, so the third one here. Your strategy, we're going to find a common denominator. Okay, so I'll draw my line. Which side do you think I want to work on? The right side. Okay, what is your common denominator going to be? Very quiet mumbles. What do we think? Okay, what are the two denominators right now? Okay, so could I make a denominator with both of those? Okay. So let's have our denominator be cosine times sine.
For the fraction on the left, you should just write it blank because cosecant is 1/sine, so that makes the denominator sine field, so you just write blank.
You'd have to show the work of showing cosecant is 1/sine, and then 1/sine over cosine is 1/cosine. Like, so you can do it in a different order than what I'm going to do it in right now. So that's fine. Okay, so guys, we had a cosine in this fraction. We now have both. So what do I need to take my numerator? Yes, so I now have sine of x times cosecant of x. And what about my other fraction? What did I take in terms? Cosine. So are you okay with me just writing cosine squared? Okay. What do we know about sine and cosecant? They're reciprocal. So what is sine times cosecant going to equal? All right, so I have 1 minus cosine squared over cosine x sine of x. Okay, what is 1 minus cosine squared equal to? Sine squared. So I have sine squared over cosine sine. Does anything cancel?
No, that's fine.
Yes. Everything is multiplied here, right? There's no plus or minuses left, so we can start getting rid of some factors. So I'm going to go ahead and get rid of this sine, one of these. So I now just have sine of x over cosine of x. What is sine over cosine? Yay, that's where we were going, yes. In some of the long proofs, make sure you look back and see where you're actually trying to go, because sometimes you'll just start wandering aimlessly and you won't realize that you've already gotten the answer you were looking for. All right, questions on that one? Are you seeing how it's a very step-by-step, organized, your work must be clear, showing every step of the process, okay? Do not skip steps. Don't do a bunch of stuff in your head and jump 3 steps. You're going to lose points on the proofs. Okay. All right. Then our last strategy, number 4 here, which I don't really have room for, you are going to rewrite with sine and cosine. Okay, which side are we working on? Good.
Right. I don't know.
You could, like,
One
I could
divided
get
by
there,
one.
but it would not be very good.
You just substitute that with like sine squared plus cosine squared for 1.
Or you could be like, okay, 1, well, that's sine over cosine, or sine over sine. And it's also sine over sine times cosine over cosine. Like, that's still 1. And start slowly.
But yeah, it's much.
It's much easier to work on the left. You could get there on the left. All right, so how can I rewrite tangent? Times cosine over sine. What happens? Okay, and when they all cancel, what are we left with? 1. Cool. You're done with that one. Okay. So far, so good? All right. Turn the page. We have 2 more strategies. Okay. The 5th one is to use Pythagorean identities. So it's good we reviewed those. Which side do you want to work on? I think I want to work on the right. You can try it on the left. You can get there that way too. All right. So it's cosine squared plus sine squared, right? Which is 1. But the other side doesn't exactly equal 1. Okay. So let's see. You could do it either way, honestly.
But you can only work on one side.
You can only work on one side. I know, that's the trick.
Yeah, why?
In regular, I let them work on both sides. No, so mean. You guys are special, though. You're honored.
I'm special.
But then, we go.
What do you want to do? There's a lot of different things you guys could do on this. What? Cosine squared plus sine squared does equal 1. Okay, let's do that side, that's fine. And then we'll go back and look at the Pythagorean identity. Okay, so everybody's with me on that step, right? Well, let's look. Didn't we talk about this? So what can I replace 1 with? Okay. This is one where you could have taken a really long way. But that works, okay? And that's only working on one side. All right. We're okay with that one? Yeah? All right. Are you starting to see how important those Pythagorean identities are to kind of get used to them? All right, and then your last strategy, we're just going to factor. Yeah.
So, if we work on the right side, we put it in terms of 1, and
Said cosine squared, yeah.
then, okay.
Now, if you were doing like a really long way, you could have been like, okay, you could have done something with cosecant squared equals 1 plus cotangent squared, and then combine your like terms and you get 1, and then turn it into that. Or you could even do 1 over sine squared plus cosine squared, you know what I mean? Like, that way space. All right, which side are we working on with number 6? I think we'll agree on this one. The left, okay. Yeah, questions?
On number 5, so I used the right side and I got all the way down the side to 1.
Okay.
What about the left side? Or after the right also the sign, like cosine and square, the sine square is 1.
Okay, if you do that, then you've worked on both sides.
And then I
So you got this side down to like equaling 1, right? Another way to write 1 is cosine squared plus sine squared.
oh, I just
So you just have to do that on that side. Yeah, that's it. Okay. So on to 6. What can I factor out on the left side? Cotangent. I am left with 1 minus cosine squared, right? Okay. Let's do 2 things in our next step. Do you see how the right side only has sine and cosine? Which means I probably want sines and cosines on the left. So what is cotangent with sine and cosine? Cosine over sine. Times, what is 1 minus cosine squared? Sine squared, right? Alright, so what's going to go away? That and one of those, right? So what am I left with? Yes. Equals 6. Questions so far?
Instead of getting sine squares, we chose switch those and your sines and sine x squares.
Don't switch this side.
No, on the left side, and then have cosine and sine x
Try making that. Try making that. It's just multiplication, so. Alright guys, so you have 6 strategies other than sitting and staring, right? We have things we can try. So, we have a giant stop sign for you here. Why are we doing this? Alright, what I want you to do is, and you can partner up if you want on this, get out your calculator, be in radians. Okay, make sure you're in the right mode. For your window, if you do zoom trig, that will be helpful. So graph all 4 of those and see what you see.
It's like trying to grab something, it takes forever.
Yeah. Yep, graph all 4. So like y1, y2, y3, y4. If you don't have a calculator, go sit by somebody who does. So if you go menu, settings, drafting equals
You can do sleeping. They're all the same.
What is C?
One over the
But it always gives me something to break that. You know, if I do like.
You have to put an extra parenthesis.
cosine, the hard.
You have to put an extra parenthesis.
No, I don't want cosine to the negative one.
Oh, that's inverse, so.
I want 1 over. So, if we're just dealing with variables, like x to the negative 1. But it was being cosine back to that.
Why is there a really one sleeping? Why don't they have buckets?
Because you have a 1 over.
It's so much easier. Let's put calculation before.
Yeah, it would be easier than
Well, it's good that this unit's all non-calculated after we get past it makes sense. It won't matter for you.
No bueno.
Most of pre-calc is non-calculated.
No bueno.
it's not. It's a weird pencil.
That's a new one.
Why do you have so much grief and
It's already broken.
He doesn't know how to
Yeah, but doing cosine, but
Guys, what are you noticing? They're all the same. So isn't that crazy? All four of these equations that look completely different are the same. If we're having graphing trouble, the separation. So guys, what the point of this is, I could give you, hey guys, listen. I could give you this equation and set it equal to this one and say you have to prove it. Okay, not today, but just, these are all equivalent. You know, this equals, doesn't look like it, but it does. Okay? All right. Do what?
we use a calculator on
No, you don't get a calculator for proofs. This is just to show you this. Guys, you're done with your calculators now, okay? You don't need them anymore today. You're not allowed to use them anymore today.
I guess pencil was really good.
I feel like you could sell it, like you said, just an eraser, and just like, rub it on your paper.
It's a pencil though. It's like pencil.
What you have to do is you gotta get one of those like giant erasers and you just color out the inside so that becomes
No,
like
what you gotta do is get a smartwatch and get a normal watch over the smartwatch so you can't see the smartwatch.
Yeah, when you have a wristband over the watch, so the time of the watch.
You just put a calculator on your wrist, something from over.
Just the changing, ever changing. Way too many ways to cheat. Alright guys, before lunch, let's go through this last one real quick. I could give you this expression right here. Good, before lunch. Alright. Cosine squared minus cotangent squared minus tangent squared plus secant squared plus cosecant squared plus sine squared. That's ugly. It's simple though. It equals 3. Okay? So you can use all of your Pythagorean identities to change this around. We know cosine squared plus sine squared. So we know that's equal to 1, right? We also know cotangent squared and cosecant squared, if I put those together. If you think about cosecant squared minus cotangent squared, what does that equal? 1. If you think about secant squared minus tangent squared, that is also 1. So this whole thing is just equal to 3. So that might be a proof. That big expression equals 3. To show me why. Okay. All right. We will continue with these after lunch. Practice a few of them. The bell will ring very soon. Okay, guys. So in your packets, we have some practice. I would like you guys to try to do these 4 right now. Start them on your own. You can certainly talk to each other to try to figure it out if you get stuck. I'll give you some time here. Ready, go. Remember, sitting and staring, not a good approach. You can sit and stare for like a minute, and then you can do all right.
One minus 10.
We were together. Yes. No way.
I think that we like to try it and start to figure out all the pieces. So
How does it work?
yes, your knowledge of fractions as well. Sounds silly, but that's usually like when you get to calculate. Think about factoring on that one.
I was thinking like 1 minus.
It is.
Oh, wait, 1 over.
Yeah, it's this other place called Steve T. Very similar.
We're gonna say,
Savannah's going out of business. They're closing, yeah. Really like tea and coffee.
I know,
Okay, so try something.
Just let me know if you want to do any
Okay. So I can multiply it with all.
Another couple minutes, we're good. No. Okay, but when you're adding fractions, let's look at strategy first. Maybe. Remember strategy number 3 here? So what if I had Okay? Okay, but your common denominator, even though that's just 1 to begin with, is 2, right? What's your common denominator? Was it 2 or was it 1? Alright, forgot to read. Good luck. Alright guys, should we look at these? Do you guys want to come through them or do you just want me to go through them?
Go through them.
You go through them?
Yeah, whole class.
The whole class of that. That's good. Alright. If you look at the first one, which side do you want to work on? I would pick the right side. Okay. 1 minus sine squared. What is 1 minus sine squared? Cosine squared. Okay. So I have cosine squared x times tangent squared x, right? We're okay with that. Can I rewrite tangent? What is it? Excellent. Okay, do things go away? Yes, these are gone. So, sine squared equals sine squared. All right. Is everybody good with number 1? First one wasn't too bad. That was the easiest one. All right, number 2. Are we in agreement that we should work on the left side? Yeah, okay. I would like a common denominator. What is my common denominator going to be? Good. So cosine squared is going to stay as cosine squared. What is sine going to turn into? Yes.
Yeah, I did that.
Okay. And what is sine squared plus cosine squared?
1.
So I have 1 over sine. And what is 1 over sine? Cosecant. Questions on that one? Okay. Good so far? All right. Which side do you want to work on for number 3? Left. Okay. What do you want to do? Sure. So, what is cosecant squared if you want to do that?
1 over sine
Times, what's tangent? Don't lose those squares, okay. And then minus 1. So sine squareds are gone, right? What is 1 over cosine? So this is really secant squared minus 1. And you can jump right to it. What is secant squared minus 1? Tangent squared. You could do that one in more steps, but this works. Good. Okay. The fourth one you had to factor. How did we do with that?
So, so the very last step you have to do exactly the same on both sides of the
All right, guys, so 4, you can factor this. This is cosecant to the 4th minus cotangent to the 4th. That's actually difference of squares. Okay, that turns into cosecant squared minus cotangent squared times cosecant squared plus cotangent squared. I mean, really? could do something with. It's without factoring. It's just kind of like if you wanted to work on the other side, you'd have to start with plugging, like you almost do the steps in reverse. So like you have cosecant squared plus cotangent squared times 1. Replace the 1 with the cosecant squared minus cotangent squared. Like that. Alright guys, so cosecant squared minus cotangent squared. You could keep factoring that, but it's not really going to help you. We know a substitution for that. So what is cosecant squared minus cotangent squared? 1. So all you're left with is cosecant squared plus cotangent squared. And isn't that where we were going? Okay. The more you do these, the easier they get because you just start to recognize the patterns and the strategies and the factoring, all of that. Okay? It just takes practice. All right. So